Good morning to one and all. My name is Saibas Reddy. Today we are discussing about the union of two subgroups of a group G. Is a subgroup of G if and only if one is contained in the other. This question is also right if H and K are any two subgroups of G, then H union K is a subgroup of G. If and only if H subset is equal to K or K subset is equal to H. Okay, here we can see an union. We can take two subgroups. Okay, then the union of two subgroups is again subgroup that is left hand side or in right hand side. We can observe first subgroup is subset of second subgroup, or second subgroup of subset is first subgroup of is containing subgroup. Okay, let we can write the proof. Suppose H comma K are any two subgroups of G. Let E is the subgroup of H. Okay, comma E is subgroup of K. Means E belongs to H and E belongs also to K. Therefore, E belongs to H union K. Means H and K. Therefore, H union K is non-empty set. Okay, claim. What we show that to show that H union K is a subgroup of G. To show that H union K is a subgroup of G if and only if H subset K or K subset H. First we can see the to show that the H union K is a subgroup of G if and only if H subset is K or K subset H. We can prove that these equations. Okay, we can first we can take necessary part. What is necessary part? Means where our supposition part is H union K is subgroup of G. This is a supposition part. Now we have to show that H subset K or K subset H. Show that H subset K or K subset H. In contingency way, supposition that H is not subset K or K subset not K not subset H. If means if H not subset K, then A belongs to H, but A does not belongs to K. Means A is subgroup of H. Okay, this not belongs to K. If K is not belongs to H, then B belongs to H, but B not belongs to H. Okay, this is also subgroup of K. If A belongs to H, comma B belongs to K, then AB H union K. Therefore, since H union K is subgroup of G, we have to consider AB belongs to H union K. Means since therefore AB belongs to H or AB belongs to K. This is considered part. Okay. That implies AB belongs to H or AB belongs to K. Now first we can see A belongs to H and AB belongs to H. Okay. Means here we can see AB is the subgroup of H. Here AB is also subgroup of K. First we can taking A, B is proving the A is the subgroup of H. A belongs to H, comma AB belongs to H. That implies A inverse whole AB belongs to H. Since H is subgroup of G, we have known that implies A inverse A whole B belongs to H. That implies into the A inverse A means E, B belongs to H. That implies B belongs to H. This is a contraction to the fact that the B belongs to H. B not belongs to H. Means here we can see that B is not belongs to H. We can see that we can prove that. Now we can take AB belongs to K and B belongs to K. Okay. Now AB belongs to K, B belongs to K. That implies AB whole B inverse belongs to K. Therefore, K is an subgroup of G. That implies A in associative, we can see B into B inverse belongs to K. That implies A means B into B inverse means E belongs to K. That implies A belongs to K. Here E means by means B into B inverse means here we are using INT law. This process. Okay. So this is a contradiction to the fact that A not belongs to K. Here we can see that now here. Okay, A is not belongs to K. You can prove that. We can prove this statements. Okay, here our supposition is wrong. Therefore, our supposition is wrong. Therefore, H subset K or K subset H. Next part we can see sufficient part. Suppose H contains K or K contains H. Now we have to show that the H union K is subgroup of G. Our proof is claim we have to show that H union K is subgroup of G. Consider H and H contains K. Okay, means H and K as the subgroup of G. H contains K. That implies H union K is equal to K. Means here we can see H and K are subgroup of G. Union means or H or K. Here H contains K means H union K is equal to K. Therefore, since A subset is equal to B, that implies A union B is equal to B. This format we can see. Okay, that implies H union K is subgroup of G. Since K is subgroup of G, again consider K contains H. That implies K union H is equal to H. Here we can see K contains H means K and H are the subgroup of G. K contains H means K union H is equal to H. Since A subset is equal to B, that implies A union B belongs to B. Okay, understood? That implies H union K is subgroup of G. That implies H is subgroup of G. We know. Therefore, if H contains K or K contains H, then H union K subgroup of G. Therefore, H union K is an subgroup of G if and only if H subset K or K subset H. Hence the theorem. Here we can see H contains K or K contains H. Means here we can, where supposition is H union K is subgroup of G. Okay,